The graphs of functions f and g are shown below. Sketch the graph of the inverse function of f on the same axis used for the function f. We know the inverse function will be a reflection in the line y equals x. So this point here at -1, -2 will reflect to -2, -1. This point here, which appears to be at about -1.5, would reflect to here. This point here at 2, 0 would go to 0, 2. And this point here at 3, 2 would go to 2, 3. So we'll try to make a reasonable job now of drawing the reflection of the function. You could always use a couple more points if you want to make sure it looks really accurate. We're now asked to explain why the inverse of g is not a function. Well, quite simply, we can see with g that g is not 1 to 1. We're now told that the defining rule for function f is as given here on this domain. We can see the domain from the graph. We want the rule for the inverse function. So this is a fairly standard procedure. We're going to let y be equal to 2 minus 2 root 3 minus x. And then we'll interchange x and y. So x is equal to 2 minus 2 root 3 minus y. And then we want to make y the subject. So we can say 2 root 3 minus y is equal to 2 minus x. If I square both sides, 4 times 3 minus y is equal to 2 minus x all squared. So that gives me that 3 minus y is 2 minus x squared divided by 4. And rearrange that to give y is equal to 3 minus 2 minus x all squared divided by 4. And therefore the inverse function is 3 minus 2 minus x squared divided by 4. We now want to determine the exact value for g of f of 0. Now if I just bring in the graph, f of 0 is this value here. It looks like it's at -1.5, but of course we actually have the function. So f of 0 is actually at 2 minus 2 root 3. So what we're doing is finding g of 2 minus 2 root 3. Now let's go to the graph of g. 2 minus 2 root 3 would be along this section here. I can see that's got a gradient of 1 and an intercept of 4. So essentially that is y equals x plus 4. So this is going to be 2 minus 2 root 3, add 4, which is 6 minus 2 root 3. Now in the final part, we want to determine the domain for the function y equals f of g of x. F of g of x means that the function g is done first, and the output from that goes into f. We know both from looking at the graph here and from what we were told above that what goes into here has to be between -1 and 3. So now we're looking at the output from g. We can see that from here to here, the output is above 3. But it's okay in this region and in this region. So we can allow into here any real values that are between -2 and -1, and between 0.5 and 2.